Good afternoon, class. We are looking at Module 4. Here's the Module 4 exam review, Chapter 8. Grab my laser pointer. Application of trigonometry, polar coordinates, and vectors. We cover 8.4, 8.5, and 8.8. Polar equations and graphs, complex plane, the Mars theorem, and vectors. Now, plot the points in polar coordinates. As you know, in the case of a polar coordinate, we have the polar axis, which is in essence, the positive side of the x-axis. We have the pole, and a pair which has coordinates x, comma, y can be represented with r, comma, theta. First, we draw the angle theta, a positive direction, of course, unless otherwise mentioned. And then we go so many tick marks. In this case, we have the angle 0, and the angle 0 is along this side. 2 tick marks takes us to the right side. -2 takes us to the left side. And the polar r, comma, theta, so that would be 2 tick marks to the left because this is negative. 1, comma, pi over 2, the positive side of the y-axis is pi over 2, and you go 1 tick mark up, and that's the graph. Find other polar coordinates for part B, reminding everybody that in the case of a polar coordinate, we have infinitely many solutions, and therefore we can add 2k pi, or we can subtract from it. If you want a negative r, you can put that as well. In this case, we want to go from -2 pi to 0. All you have to do is subtract 2 pi. Gives us -3 pi over 2. In this case, we want r to be negative, so just add a pi. And in this case, 2 pi to 4 pi, add a 2 pi, and so get 1 pi over 2. In short, this is the situation, everybody, where we can add 2k pi. If you want to keep the r with the same sign, if you want to change it to its opposite, you add odd multiples of pi in essence. That's the methodology. All right. Plot the points first, then find their coordinates, find the rectangular coordinates. So this one, we are going to go from one format to the next, and we make 150-degree angle, and we go 6 tick marks. So that means 6 circles in essence. Each one represents a 1. See, 1, 2, 3, 4, 5, 6. So that's why we have this point. And now, reminding everybody the relationship between the two, a polar versus rectangular, is that x is r cosine theta, y is r sine theta. And so with that being the case, x is 6 cosine of pi over 6, and 5 pi over 6 is a common arc. And cosine is the same as pi over 6, which is square root of 3 over 2. However, it's negative because it's in the second quadrant. Makes it -3 square root of 3. Y is r sine theta. Again, it's a common arc. 5 pi over 6, the same as pi over 6. Sine is positive in the first as well as the second quadrant. Therefore, it's 1/2. 6 times 1/2 makes it 3. And so the coordinate 6, comma 115 polar is the same as -3 square root of 3, +3 in rectangular coordinate system. What about 2, comma -2? So we go 2 units to the right and 2 units down, because you can think of this as a rectangular coordinate system as well. Okay. And the relationship is that x squared plus y squared equals r squared, and tan theta is y over x, adjust for the quadrant. And so x squared plus y squared equals r squared means 2 squared and negative 2 squared, they add up to 4 and 4 is 8. R is the square root of 8, and as you know, square root of 8 is 2 square root of 2. Tan of theta is y over x minus 2 over 2 is negative 1, and theta is negative pi over 4. Now, of course, if we want to have this from 0 to 2 pi, the first revolution, all you have to do, add 2 pi. If I add 2 pi, that means 8 pi over 4, I get 7 pi over 4. So you can add 2 pi to bring it. So if the question is, okay, make sure it's between 0 and 2 pi, then you have to add 2 pi. Transform the polar equation r cosine theta equals negative 2 to an equation in rectangular coordinates and graph. Well, on the one hand, r cosine theta is negative 2. On the other hand, x is r cosine theta. Therefore, x equals negative 2. It's a vertical line, everybody. So you look at negative 2 and you draw it, and there you have it. We're going to repeat the same way with this case, r equals 2 cosine theta. And we're going to write x is r cosine theta. We know r squared is x squared plus y squared. We know r is 2 cosine theta. And the technique when we have r and either sine or cosine, the technique is to multiply both sides by r. When we do that, this becomes r squared. So let's multiply by r. This becomes r squared. This becomes 2r cosine theta. We know r squared is x squared plus y squared. And 2 cosine theta, r cosine theta is x. So it's 2x. Now, we bring the 2x to the left and combine it with x squared. B is negative 2. Completing the square, everybody. Divided by 2 is negative 1. Squared is positive 1, so you're going to add 1 to both sides. Then we have x minus 1 squared plus y squared equals 1. And as you recall, here's the equation of various circles. X squared plus y squared equals r squared, centered at 0, 0. X minus h quantity squared plus y minus k quantity squared equals r squared, centered at h and k. Therefore, this represents a circle centered at 1, 0, 1. There's nothing next to it, 0. And the radius is the square root of 1 or 1. So we are going to go with two tick marks because otherwise it becomes too small to represent one. So normally this is one, but we're going to go here and so two tick marks, 1, 2 represents one, and then we draw a circle. Just wanted to make, I just wanted to make sure the graph looks good. Otherwise, you really don't have to go with the two tick marks. It's your choice. Transform the polar equation r cosecant theta equals 8 to an equation rectangular coordinates and graph. So cosecant is 1 over sine, so this is r over sine. If we multiply both sides by sine, we get r equals 8 sine theta. And now the technique, anytime we have r and sine or cosine, is to multiply by r. So we're going to multiply both sides by r. The result is r squared equals 8r sine theta. R squared, we know x squared plus y squared equals r squared, and we know r sine theta is y. Therefore, you're looking at x squared plus y squared equals 8y. Again, we move the 8y next to, this time next to y squared. And in this case, here's b divided by 2, square it. So add 16 to both sides. And so what happens is, this is x squared, this is y, and including the b over 2, whatever the sign is. So y minus 4 quantity squared. And again, reminding you of the circle, this is centered at 0, 4 with the radius square root of 16, which makes it 4. So 0, 4. I'm going to go with only one tick marks, 1, 2, 3, 4, and then the circle. Okay. Identify, graph the equation, convert it to a rectangular equation, and so forth. So anytime, so we have some information here, and when r is given, just square both sides. Clearly, r squared is x squared plus y squared, and that makes it a circle centered at 0, 0 with the radius 4. So I hope you recognize this is the rectangular form, this is the polar form. Polar form in this case is a lot easier. Centered at 0, 0, radius 4, so 1, 2, 3, 4, and so forth. Theta equals 3 power 4. The technique is to take the tangent of both sides simply because we know tan of theta is y over x. So tan of theta, which is y over x, is also tan of 3 power 4, which is negative 1. Which means this represents, if you do the cross product here, y equals minus x. So this represents a line through the origin. Y equals x is this way, y equals minus x is this way, y equals x goes through power 4, this one goes through 3 power 4. Okay, again, y equals x would have gone through power 4, okay? But negative x through 3 power 4. We continue with graphs, convert to rectangular equation. So r sine theta equals -3. As you know, r sine theta is y. Therefore, we are looking at y equals -3, which is a horizontal line. So 3 tick marks down and a line. Our cosine theta is x. Therefore, this is x equals 4, which is a vertical line. And so x equals 4, you tick mark 1, 2, 3, 4 tick marks, and you draw a vertical line. So when r equals a, we have a circle center at the pole with the radius a. Theta equals a is a line, y equals tan alpha times x. Horizontal lines r sine theta equals a constant, a number represents y equals a. Vertical line r cosine theta equals a represents x equals a. And r equals plus minus 2a cosine theta or plus minus 2a sine theta represents a circle. In all of those cases, a, the radius is a, and depending on whether you're dealing with cosine or sine, with the case of a cosine, since it represents, in essence, cosine represents the x, so it's along the x-axis, the center. In the case of a sine, along the y-axis. The concept of a symmetry we know in a rectangular coordinate system. Also, let's discuss it with respect to polar system with symmetry with respect WR2, the polar axis or the x-axis. If in the polar equation r comma theta can be replaced by r comma negative theta, resulting in an equivalent equation, the graph is symmetric with respect to the polar axis. So take a look. Symmetry with respect to the line theta equals pi over 2, in essence, the y-axis. If in the polar equation r comma theta can be replaced by r comma pi minus theta, the graph is symmetric with respect to the line theta equals pi over 2. So with respect to a symmetry with respect to the pole or the origin, if in the polar equation r comma theta can be replaced by negative r comma theta or r comma theta plus pi, the graph is symmetric with respect to the pole. So you have to check both of them. Sometimes one fails, but the other one works. Needless to say, if these two are in order, they result in a symmetry with respect to the pole. In other words, if it's symmetric with respect to x and y axis. Graph r equals 1 minus cosine theta, and we basically plot easy points. Okay. Remember that r equals a times 1 plus minus cosine theta, or r equals a times 1 plus minus sine theta is a cardioid as long as a is positive and passes through the pole. So theta is r equals 1 minus cosine theta, r comma theta. Let's pick up a few easy numbers. For example, 0. Class, if I put 0 here, as you know, cosine of 0 is 1. 1 minus 1 gives us 0. Pi over 6 gives me square root of 3 over 2, 1 minus that. Pi over 4 gives me square root of 2 over 2, so 1 minus that. Pi over 3 is 1 half. 1 minus 1 half, that's easy, it's 1 half. Pi over 2 is 0, I get 1. 2 pi over 3 is the same as pi over 3, but it's negative because in the second quadrant, cosine is negative. So 1 minus negative 1 half, which makes it 3 halves. Pi gives me negative 1. 1 minus negative 1 is 2. So we are going to plot the easy points, 0, 0. And by the way, again, we're going to go with 2 tick marks because we want to show a better graph. So 1, 2, 3, 4. So 2 tick marks represents 1. So 0, 0 is the pole. By the way, the pole r comma theta, as long as r is 0, theta is anything else, that represents the pole. 1/2 pi over 3. So find pi over 3 and go 1/2. Pi over 2 is the positive side of the y-axis. 1, we said 1 is going to be 2 tick marks. 2 pi over 3 and 3/2, that means 3 tick marks. Okay. 2 pi is this way, and 2 tick marks, we're going to go with 4 because, so the graph looks something like that. Now, I can pick more points and graph them, but I want to discuss the symmetry at this point. R equals 1 minus cosine of negative theta. You know cosine is an even function, so it's the same as cosine theta. So when I change the theta to negative theta, I receive the same R. Therefore, it makes it symmetric with respect to the polar axis, the x-axis, because r comma theta can be replaced by r comma negative theta, resulting in an equivalent equation. The graph is symmetric with respect to the polar axis, meaning you can follow that. And that's the rest. You can do that. Or you can go with easy numbers again, just for the sake of argument. 4 pi over 3, remember, is the same as 2 pi over 3 because both of them are negative. So this is also 3/2. 3 pi over 2 gives you 0. 1 minus that is 1. 5 pi over 3 is the same as pi over 3, but negative. So 1 minus 1/2 is 1/2. 2 pi is the same as 0. And so you plot those and it looks like that. Plot the complex number 1 plus I in the complex plane and write it in polar form. Write theta in degrees. Okay, first and foremost, a complex number a plus bi, we've seen it before, x plus yi, we can write it in the form of r cis theta. That would be this is the standard form or rectangular form. This is the polar form. So r cosine theta plus I sine theta. This is the shorthand notation. R squared is x squared plus y squared. This is the magnitude, or r, the same as before, square root of x squared plus y squared. Tan theta is y over x. You always adjust for the quadrant. And so this is the case here. This is the graph for this is the real, this is the imaginary line, and this one, 1, and this is 1i. So I'm going to go with 2 tick marks again. Okay, 2 tick marks equals 1 because otherwise it will be too small. So this represents 1, 2, 1, 2. Okay, 2 tick marks. And so that's that. Let's move on. And so it refers to that point. Or is square root of x squared plus y squared. 1 squared plus 1 squared makes it 2, square root of 2. Tan theta is y over x, 1 over 1. It's a common arc. Theta becomes 45 degrees or pi over 4, but they want it in degrees. And so so this is the angle that we're talking about, 45 degrees. Z, which is 1 plus I, or r cis theta, would be r cosine of 45 degrees plus I sine of 45 degrees. Or a shorthand notation, we could write in this fashion. That means the same thing, everybody. Write the complex number 4, cosine of 7 pi over 4 plus I sine 7 pi over 4 in rectangular form. So RC theta, just plug in, evaluate, and come up with the answer. So first and foremost, you can rewrite this in this fashion. 7 pi over 4. It's a common arc. Pi over 4 results in the square root of 2 over 2. And 7 pi over 4 cosine is positive in the fourth quadrant. This is the fourth quadrant. So positive square root of 2 over 2, but sine is negative, minus square root of 2 over 2. You multiply the 4, and this goes away. So we get 2 square root of 2 minus 2 square root of 2i. So 7 pi over 4, you draw a line, and you go 2 square root of 2, 2 times square root of 2, 2 times about 1.4, about 2.8 tick marks. Okay. It's close to 2.8. It's close to 3 along the x-axis and negative 3 along the y-axis. It's not to scale, but it's close. Find ZW, Z times W, and Z over W, and leave the answer in polar, where Z and W are given as follows. And reminding everyone, if we have Z equals RC theta, then Z1 times Z2, we multiply their magnitude, R1, R2, and then cis theta 1 plus theta 2. We add up their arguments. For division, we divide R1 by R2, and cis, we write the difference of the arguments. For this, we are going to say 2 times 2. They happen to be the same. 2 times 2. Okay. And then cosine of pi over 8 plus pi over 10. I sine of pi over 8 plus pi over 10. The common denominator is 40. This is 5 pi over 40. This is 4 pi over 40, makes it 9 pi over 40. So just in case, 40. Division, we divide the two numbers, they cancel each other, and we subtract the second argument from the first one, and we said this is 5 pi minus 4 pi this time over 40. So it gives us pi over 40. So that's pretty straightforward, everyone. We want to write this in standard form, or a plus bi, and we want to raise this to the power of 6. So reminding everybody of the Moir's theorem. So if you have r cis theta and you want to raise it to the power of n, you raise the r to the power of n, and then you multiply the argument by n. So we are going to raise this to the, so 1z to the power of 6. We want to raise this to the power of 6, and we want to multiply the argument by 6. So obviously square root of 3 to the power of 6 is 3 cubed with the, and then 6 goes away, 18 becomes 3. 5 pi over 3 is the same as pi over 3 for cosine and negative for sine, because in the fourth quadrant, cosine is positive, but sine is negative. And Cosine of power 3 is 1/2. Sine of power 3 is square root of 3/2. And you can distribute the 27. You get 27/2 minus 27 square root of 3/2 I. So that would be the final answer. Given z equals 1 plus I, find z to the power of 10. We've already done 1 plus I, and we ended up with square root of 2 cis 45 degrees. That was done in one of the previous questions, okay, more specifically, question 9. And so what do? We use that. We're not going to go over it again. And we are going to follow the De Moivre's theorem. We want to raise this to the power of 10. That means we're going to raise square root of 2 to the power of 10, and we're going to multiply the argument by 10. So to the power of 10 and argument by 10. So that's very straightforward, everybody. So what we get here is 2 to the power of 5. What we get here is 450. And as you know, we can subtract 360. That makes no difference. It gives you the same value, which gives you 90 degrees. By the way, 2 to the power of 5 is 32. Cosine 0, sine 1, the answer is 32i. Z equals 8, find all complex cube roots. 8 is 8 cis 0. Okay, so, and I'm going to discuss that in a moment, but first I want to discuss the following. If the number is positive, everybody, for example, is 8, becomes cis 0. But if it's negative, let's say it was minus 8, then it would be 8 cis pi or 8 cis 180 degrees, okay? Just the R is always positive, R cis theta. So the angle 0 for positive values, the angle 180 or pi for negative values. That's the first thing I want to discuss. So this is clearly one of those we should know. One of those easy numbers. The second thing I want to explain is that if you want to take the root, okay, and it's in that format, R cis theta, you get the nth root of R and cis. You divide this by n and you add either 360k or 2k pi or over n, okay? So this is divided by n also. So according to this happened to be 0, so it doesn't do anything. So 2k pi over 3, and it's cube root, so the third root of 8, which is easy, it's just 2. So this has no bearing, everybody. But I wrote the 0 because if it were something else, anything else, you have to divide it by 3. So in short, z sub k, that means the root becomes 2 cis 2k power 3, and k goes from 0 to 2. If you go to 3, it repeats itself. Just think about this. If I replace the k with 3, 3 cancels out the 3, I get 2 pi. So it repeats itself, okay? So z sub 0, so let's replace the k with 0. We get 2 cis 0. With 1, we get 2 pi over 3. With 2, we get 2 times 2, 4 pi over 3. So replace the k with those numbers. This is simply true. If you plug in and evaluate it, cosine is 1, sine is 0, so you get 2. You plug in 2 pi over 3. Remember, it's the same as pi over 3 in the second quadrant. Cosine is negative, but sine is positive. So when you multiply by 2, this goes away, becomes minus 1. This goes away, becomes square root of 3. So Z1 is minus 1 plus I square root of 3, or square root of 3 times I. 4 pi over 3, again, is the same as pi over 3, but we have to figure out the sign. And both of them are negative, because in the third quadrant, sine and cosine are both negative. So this is negative 1/2. This is negative square root of 3 over 2. And we get rid of the denominator too. We get minus 1 minus I squared of 3. Let's switch gears and get into vectors. Vector has initial point P and terminal point Q. Write V in the form of AI plus BJ. Find its position vector. Also find its magnitude. And here's P, here's Q. All right. So if you have a vector in general, basically you move that such that the initial point is at the origin is called the position vector. So remember, the vectors are identical as long as they are parallel and they have the same magnitude. So this is x sub 2 minus x sub 1, like this one. This is y sub 2 minus y sub 1, like this one. So position vector. If V has components AB is an algebraic vector whose initial point is at the origin, when V is called, then V is called a position vector. Algebraic vectors are in the form of AI plus BJ, or A comma B. A and B are called component of the vector. A vector with initial and terminal points x sub 1 and y sub 1, a sub 2, x sub 2 and y sub 2 is equal to the following. X sub 2 minus x sub 1, y sub 2 minus y sub 1. And so with that being the case, we are going to write 5 minus 3, 6 minus 2. This gives us 2, this gives us 4. We can also go with the I method, say 5 minus 3 times I, 6 minus 3 times j, okay? Because this is the same as 3I plus 2j. Okay, let me just write the second one, is easier. So this one, for example, this one is the same as 5I plus 6j. Okay, so you represent it either way. If you go that route, 5 minus 3 is 2I, 6 minus 2 is 4j, or just write 2I, 4j. The magnitude is square root of a squared plus b squared. Okay, the magnitude is square root of a squared b squared, and the magnitude is 0 or positive. If the magnitude is 0, the vector must be a 0 vector. And the magnitude of two vectors that are opposite is the same. And if you multiply it by a, you can bring out the absolute value of it. So a squared plus b squared in this case means 2 squared plus 4 squared under the radical. This is 4, this is 16, they add up to 20. And you should know 20 is 4 times 5. 4 comes out as 2, 2 squared of 5. This is an exact answer. Most likely they want an exact answer. You want to stick with this, the exact answer, everybody? Okay. Unless they ask for an approximation, then they say how many decimals, you go to the next one to make a decision. All right, V and W are given. We want to find the magnitude of V first. So we're going to follow square root of a squared plus b squared. A is negative 2, b is 3. So this gives us 4, this gives us 9. we get square root of 30. V plus W, that means add the two, minus 2i and 5i is 3i, 3j, and minus 4j is minus j. 2v minus 3w means 2 times this vector minus 3 times this vector. So you do the component-wise. Distribute, you get minus 4i plus 6j minus 15i plus 12j negative 19i plus 18j. Find the magnitude, direction, angle, and a unit vector in the same direction for this vector. Well, the magnitude is basically a squared, b squared under the radical, so 3 squared and 3 squared. That is 9 and 9, 18, and by now we should know 18 is 3 squared of 2. So that's the magnitude. We want the angle. Tan is b over a. So remember, in order to get the angle, tan is b over a. Tan of alpha, sometimes we call it theta, sometimes we call it gamma. Okay, whatever. A vector is equal to its magnitude times cosine alpha I plus sine alpha j. And the direction angle between 0 and 360, it's between the vector and the positive side of the x-axis. On the other hand, the y-axis, that's y-axis, this is the j-axis. So b over a is 3 over 3, and it's important to know it's in the first quadrant. That gives us 45 degrees or power. So the vector, therefore, is 3 square root of 2 that we found here, cis, if you will, cosine 45 degrees I plus sine 45 degrees j, not cis. Cosine 45 degrees I plus sine 45 degrees j. Now, what is a unit vector in the same direction? You basically divide the vector by its magnitude. So unit vector in the direction of v is v divided by its magnitude. Okay. By the way, I is a unit vector 1, 0, j is a unit vector 0, 1, a times 1, 0 plus b times 0, 1 is ai plus bj. So the unit vector is this. The vector is this one. So divided by this number. That's all. So 1 over square root of 2, as you know, 1 over square root of 2 is square root of 2 over 2. If you want to rationalize, it's the same thing. Magnitude, angle, we wrote it in this format, and we wanted the unit vector in the same direction. Write the vector v in the form of ai plus bj, given its magnitude and the angle a it makes with the positive x-axis. Also find the unit vector in the same direction for the vector and check its magnitude to be 1. So here's the magnitude, here's a, basically plug it into this one. That's all they say. So the magnitude is 14, alpha is 120 degrees. So the reference arc is 60 degrees. So they have the same value as the 60 degrees. Cosine of 60 is positive 1/2, but this is the second quadrant, negative 1/2. Sine of 60 is square root of 3/2, and sine is also positive in the second quadrant. We divide 14 by 2, and we get minus 7i plus 7 square root of 3j. So that's in the form that they asked. Now, the unit vector in the same direction, all we have to do divide by the magnitude, and the magnitude we don't have to calculate. It's given as 14. That's divided by 14. And as we do, we can factor the 7 out. We get minus 1/2 I plus square root of 3/2j. We are done. The last part is checking. Checking a unit vector. A unit vector, by definition, is a vector whose magnitude is 1. So all you have to do is square these two parts. This gives you 1/4. This gives you 3/4. They add up to 1. And of course, square root of 1 is 1. Even if you stop here, that is a check because square root of 1 is 1. So to find out whether it's a unit vector or not, you have to find its magnitude, everybody. A plane is flying at a speed of 200 miles per hour on a bearing of north 55 degrees east. The wind is blowing from west to east at 35 miles per hour. Approximate the ground speed of the plane to the nearest mile per hour and the true course of the plane to the nearest tenth of a degree. So it's going this way, north 55 degrees east, and the angle it makes with the positive side of the x-axis is 90 minus that 55, which makes it 35 degrees. So this is 35 degrees. So the magnitude is 200 miles per hour, and the alpha, theta of alpha with respect to the air, theta of A. So this angle is 35 degrees. The wind has the magnitude of 35 miles per hour, and it goes from west to east. It goes this way, west to east, that it's parallel to the x-axis. That makes a 0-degree angle. So that the reason this is 0, because it's parallel to the x-axis, right? Let's write them in this format. Let's write both of them in this format. So this would be a 200 times cosine of 35i plus sine 35j. And this is the true course, everybody. By the way, the true course makes this angle, which we call a theta. After we find the magnitude and theta, the true course would be north, east. What's in between? 90 minus theta. So north, 90 minus theta east. That's what's going to happen, everybody. This is the magnitude. North, 90 minus theta east. All right. So with that being the case, let's rewrite this as I mentioned. 200 cosine of 35 degrees I, sine of 35 degrees j. Now, this is not a common law. You have to put it into a calculator. You end up with the following. We do the same thing for the wind, and it becomes 35 cosine 0 degrees I, sine 0 degrees j. As you know, cosine is 1, but sine is 0. So simply 35i. And The velocity with respect to the ground, we add the two vectors. When you add two vectors, you add their components. So these two will get added up because they both have the I component, and this one just remains unchanged. So this is 163 and 35, 198.83 I. This one doesn't change. And now the magnitude for this is the true speed, if you will. So the magnitude would be square root of a squared plus b squared, which means square this number under the radical. You do the math, you put it into a calculator, it ends up being about 230 miles per hour. So that is the speed. Tan of theta is b over a. So this component over this component, the numbers, results in almost 30 degrees. So if this is 30 degrees, this must be 90 minus that. So that means 60 degrees. So we are doing 230 miles per hour, north, 60 degrees east. The dot product of two vectors has many applications with the following algebraic definition. We have two vectors. Their dot product is simply A1, A2 plus B1, B2, which is just a number. The symbol V dot W, the dot product is also known as the scalar product or the inner product. The result is a real number and not a vector. The properties are that when you dot two vectors in any order, makes no difference. When you dot it with the zero vector, ends up being zero. When you dot it with itself, it gives you the magnitude squared. If you multiply alpha, this is multiplication. Alpha is a real number. This is dotted. Then you can distribute it. And as we said, the dot product is A1, A2 plus B1, B2, or is the magnitude of V times the magnitude of W times the cosine of the angle in between the two vectors. So angle between the two, so if I want to find cosine, I'm going to divide this one by the product of this one. So take a look at this one. From here, you can find the cosine. Okay. So that's the synopsis of the dot product. Now, we want to find the dot product for these two, and we want to find the angle in between. So just simply put, we follow the formula A1, A2 plus B1, B2, which means 4 times 1 plus negative 3 times 2. This is 4, this is minus 6. They add up to negative 2. So that is easy. To graph them, by the way, so just locate 4 minus 3. Locate 1, 2. And those are the two vectors. Okay. It's very simple as far as graphing. Now, cosine is this. The magnitude of V, let's go to the V vector, okay, and so in this case, the first one, 4 squared and negative 3 squared, and this one is 1 squared and 2 squared, under the radical each one. So this is 4 squared. Let me just write this so everybody can see that this is 4 squared. This is negative 3 squared. This is 1 squared, this is 2 squared. And so we get 25, which comes out as 5. We get 5, which doesn't come out. If you multiply by square root of 5 over square root of 5 to rationalize, the denominator becomes 25. So what is theta? Cosine inverse of this number. So the angle in between is 100.3 degrees. This angle is 100.3 degrees. Show that the pair of vectors is orthogonal. So what do we mean by orthogonal vectors? Two vectors are orthogonal when the angle between them is a right angle, 90 degrees. The dot product of two orthogonal vectors is 0, theta equals power 2. And the reason is this, because when you dot them, you can find this method or this method. If you go with this method and this is 90 degrees, cosine of 90 degrees is 0. That's what we get. So let's multiply. So we are going to say 2 times 6, which is 12. And then 3 times negative 4, negative 12. We end up with 0. And that's a proof. Show that the two vectors are parallel. And here's the definition of a parallel. Two vectors v and w are parallel when the angle between them is either 0 degrees, theta equals 0, the vectors point in the same direction, or 180 degrees, theta equals pi, the vectors point in opposite direction. In other words, v equals alpha times w. So the easiest one is if you notice, for example, that this one, if I multiply this one by 2, I get this one. If you notice that W is 2 times the V, or V is half of W. So one is multiple of the other. That's a proof. You're done. The second method is to use this formula and find the cosine. So to dot them, 3 times 6 is 18, plus negative 1 times negative 2 is plus 2 times the top. And the magnitude of this one is 3 squared plus 1 squared, which is 10. And this one is 6 squared, 36, and 2 squared, 4, which is 40. So I hope you see I've skipped a step here. 18 and 2 is 20. The product of those 400. 20 is the same as square root of 400. The answer is 1. If cosine is 1, theta must be 0. And that's the proof, everybody.